So I totally didn't just film a video while not recording. Yeah, no, I totally didn't do that. Oh my gosh. Okay, new plan. I'm just gonna start with this video. If I made a 48 minute video on questions 1 to 6. It's super long. If you want me to post it, I will. But things really hit the fan in around question 7. So I'm going to pick up from here. If you have a specific question, I have no problem trying to help it. By doing this, honestly, it helps me understand it more, like truly. So question 7, I got a different answer than what was available. I suspect Scott may have fucked up, but perhaps I did. I'm gonna ask Scott about that. So we'll do question 8 and 9 together in this one, and the things I say in 8 are going to help for question 9, so bear with me. I promise you, if you're lost, this should help. Again, everything's already written down. So in question 8, it's saying a standard air conditioner has a return of 80 degrees dry bulb and 65 wet. The supply air is 60 dry bulb and 50 wet bulb. The outdoor air temperature is 82 degrees Fahrenheit, and the discharge air has 40 grains per pound of air. Find the BTU of the condenser if the fan was moving at 800 CFM. So right here, when it says find the BTU of the condenser, that means anything to do with the evaporator is irrelevant in this question. However, we are going to plot it because I'm going to try to avoid making videos. If I can get the point across in these 2 questions for every question, then so I'll do this. So all we have for our condenser side is 82 degrees Fahrenheit and a discharge of 40 grains, right? So this is your oat dry bulb, and you need your discharge air dry bulb. But all they give you is the 40 grains. So before we do that, there is a few things you need to know. Hold on a second. Can I do back here? Yes. Okay. This one's for Ahmed, design conditions, which this is, I need this in order to explain question 9. If you don't know this, you really should. So before any test, I write this down. It goes supply air, 2, return air, 2, saturated suction temperature, 2, suction line temp, discharge air, 2, outside ambient temp, 2, saturated condensing temperature, 2, liquid line temp. Now, again, this is design conditions. So your TD, which happens between your return air and your saturated suction temperature, is negative 40. TD. Your TD of your condenser is plus 30. Your evaporator delta T. Your evaporator delta T is half of your TD, and that is plus 20. And your condenser delta T is half of your TD, which is negative 15. Superheat under design conditions is plus 15, and subcooling under design conditions is negative 10. A little trick, if you don't know this, again, I write this at the as soon as the test begins. Get this fucking down, especially if you don't memorize it. Like, if you have trouble memorizing it, get it down. One thing to help you memorize it is it goes plus 20, negative, plus, negative, plus, negative, right? So even at the very least, if you can go like plus 20, negative 40, negative 15, and know that it's the opposite down here. Anyways, however you remember it, you need to do it. And if you don't know how it works, it's very simple. If you had if your if you have your RA and you need to get to your SLT, you're going to, whatever your number is, minus 40, that'll give you your SST, plus 15, that'll give you your SLT. And if you're going backwards, it's reverse. So, like for example, if you had a 65 SLT and you needed to know your supply air, you go 65 minus 15 is 50. Not minus 40, but plus 40 is 90, is your RA. And then not minus 20, or not plus 20, but minus 20 is 70, so your supply air would be 70, and that's how that works. Okay, so what do we know? We know in this question our outside ambient temperature is 82 degrees, and the discharge air has 40 grains. So we're going to plot, I plotted everything, but I'm not going to go through it. Again, if you need something specific, just message me and I'll walk you through it. So 82 is this discharge line, right? And then 40 grains goes all the way across. All you need is 2 points, and you can calculate everything in Psychometrics. So, for example, we have our grains, and we have this, which gives us our point. From that point, if we go diagonally, that gives us our wet bulb, and it gives us our BTUs per pound. If we go to the left side of our grain line, that's our dew point. And if you notice like these relative humidity lines that kind of curve up, if you follow that, so like here it's in between, it's in between 20 and 30. Let's say it's like 24% relative humidity. So that's all you need to know in terms of graphing. You get 2 points, you can get everything. So we have currently, we have our 82 and we have our 40 grain line, but we need to know, we don't need to know this line, but how we get this line is what we need to know. Scrap that. I mean, that's true, but we have 82, we have our 40 grain line. We need to, sorry, I'm explaining this bad. 82 and 40. Let's get our discharge air dry bulb. How do we do that? Well, because nothing's given or specified, we are going to assume these are design conditions, okay? So we have an outside ambient temperature of 82. And that's dry bulb. And we want to find our discharge air temperature dry bulb, right? And in order to do that, we are going to take 82, we are going to not minus, but plus, because we're heading the opposite direction. So 18 plus 15 equals 97 dry bulb. Right? See how I did that? So you can plot your 97. You, from those, can take those points to get your BTUs, but it's kind of irrelevant because we're looking for the BTUs, the condenser. Find the BTU of the condenser if the fan was moving 800 CFM. Your condenser is a 100% sensible exchange, which on a side note I find weird because when we drew our refrigeration cycle, wasn't the evaporator and the condenser latent? Like it's both. Anyways, back to class. So because our condenser is a sensible, 100% sensible exchange, we are going to use, you might want our sensible heat formula, which is BTU an hour equals 108 times CFM times delta T. You can screenshot this page if you want, just some random info, but good to know. Anyways, like I said, we didn't need to plot this. We could have just knew delta T was 15. But the process, the journey. I feel like I'm slipping. Anyways, sensible heat formula, BTHU times 1.08 times 800 CFM, because that's what it says in the question, times delta T, which is 15, which we know delta T is 15 already. Once you do that, you get an answer of 12,960. And that's that. Question 9. This question is something else. But everything I just kind of mentioned before is going to help us. See, didn't mean to do that. So question 9 is, a standard air conditioner is running with a saturated suction pressure of 101.2, a saturated condensing pressure of 318.1. If the return air has a wet bulb temp of 60 and the supply air has a wet bulb of 45, find the grains removed. So first thing I notice in this, if you want to find the grains removed, the condenser doesn't remove grains. So really this is irrelevant to the question. So let's go through it. We know an SCP of 101. You're going to use your chart, and that comes to, I wrote it down, hold on. SCP comes out to SST equals 32.1. We'll just say 32. And your SCP, which is irrelevant, comes to 99.9 or 100. With that said, now that we have our SST of 32.1, we need to find our RA and our supply air. And all we have is this pressure and our wet bulbs for the return and for the supply. So we need to find both dry air for return air and supply air. And you can do that with this guy, right? So we have 101.2 pressure on the suction side. 101.2, which equals 32. Oopsie. Which equals 32, right? Now we need, oopsie, that's the wrong side. It's supposed to be up here. 32. Bear with me. So we need our RA and we need our supply. How do we do that? We take that 32, we add 40, not minus, because we're going left. So our RA is 72. Then for our supply air, we're not adding 20, we're going to take away 20. So that becomes 52. So we know that our dry bulb for SA, for supply, is 52, and our dry bulb for return is 72. Now, take that, take your 52, zoop, take your 72, zoop. In the question, it says the return air wet bulb is 60 and 45 for the supply. So we go to 60. Again, wet bulb is always diagonal. Draw that. 60. Draw it till it intersects with that line. And you can get your BTU. You can get your dew point. You can get your grains. We're focused on grains, right? So, boom, boom, that gives us our point. We draw this across to get our grain of 58. Then we go to our 72, our return air. Oh, shit. No, sorry. We got to do the supply air. We just did the return air. The supply air has a wet bulb of 45. So 52, we find the 45. Again, wet bulb is always diagonal. Zoop. And you might as well just make the line just for good practice. Once you get that point, you can find your grain, which is 32. 58 minus 32 equals 26. So yeah, I'm going to stop there. I've spent a lot of time on these videos, feeling insecure a bit. I'm hoping this actually does help people, but I'm going to just post this video, and if anybody wants something more, something specific, or just maybe as a whole, ask, and I'll attempt to do it. I don't mind. It truly, by doing this, really does help me. It really does. So I don't mind doing it at all. Anyways, I do hope this helps. And yeah, thanks for watching.